5.4, number 57, cost for marginal cost. The marginal cost of printing a poster when X posters have been printed is this. So you know it's marginal because marginal means the derivative, how fast something is happening. So the rate of change of the cost would be dc dx, and that's the equation. Find c of 100 minus c of 1. Okay, so that's dc dx, so c would be the antiderivative of it. So the cost of 100 minus the cost of 1. So that's posters 2 to 100, because we've already created one poster, and now we're going to find the amount after that one. So we're going to go posters 2 to 100, or starting right after 1 would be integrating from 1 to 100. So that's what we're going to do. We're going to integrate starting from 1 to 100 of our differential equation, and then evaluate it using the fundamental theorem of calculus. Okay, so antiderivative of that, so that's 1/2 x to the negative 1/2. Writing it that way may help. So I'm going to add 1, so that becomes x to the positive 1/2. I still have a 1/2 out front, and now I'm going to divide by 1/2 or multiply by 2. So it square root of x. Square root of x is the antiderivative of that. And we're going from 1 to 100. So it's the square root of 100 minus the square root of 1. They use nice numbers here, so we get 9. So the cost in producing posters 2 all the way to 100 is $9. The cost of producing posters 101 to 400 is the same integral, or same antiderivative, but our integral is now from 100 to 400 of our differential equation, which is 1 over 2 square root of x dx. So that becomes the square root of x from 100 to 400. So square root of 400 is 20 minus the square root of 100 is 10, so it's $10. So if I was running a company, that's a good sign that doing posters 2 to 100, so 99 of them, it's going to cost you $9. Doing basically 300 of them, the next 300 is only going to cost you $10 more. So the cost of producing each poster is going down as the number of posters produced increases.